Wilson is one of Megapeter's data analysis consultants. Wilson has an excellent ability for telling the story of insights by using appropriate data visualizations and performing thorough analysis. Currently, he is working on techniques for fact extraction from large volumes of associated textual documents. If you have any questions during this webinar, please submit them through the provided. Wilson will answer your questions during the Q&A session that we'll have at the end. All right, let's get started. Wilson, would you please tell us about the details involved with converting documents to a standardized form?
Morning, everyone. My name is Wilson. And in this presentation, we will talk about how to converting Pharma documents to standardized form. I will use one real project example to show how we can use our system to automatically extract target information in the Pharma documents and convert them in the standardized form. So first, let's have a little background introduction. Idmp, the full name is Identification of Medicinal Products. It is an industry regulation that pharma companies must comply with in Europe Medicine Agency. The main object of the Idmp is to provide the basis for unique identification of medicinal products. In addition to provide the unique identification on 5 different levels of medicinal products, Idmp requires pharma companies to exchange specific Idmp standardized data to the competent organizations. This standardized data related to approximate 200 to 300 mandatory and optional fields provided in the Idmp standards. Mapping and standardizing source data to these data fields. Pharma companies with European marketed products are facing a significant data standardization challenge regarding adoption and compliance to the Idmp. And the challenge is largely coming from data management across organizational and limited time frame perspective. So let's take a close look at the Idmp documents. In total, Idmp have 5 standards, and they provide data elements and structures to uniquely identify and exchange information on substance, units of plantations, routes of admissions and packaging, and units of measurements and regulated product information. There are 2 important portions of Idmp files, also 2 reference documents. They are called SMPC and Module 3. SMPC refers to summary of product characteristics, and Module 3 refers to composition of manufacturing documents. Indications, packaging, composition, and further document information may be found on the SMPC, whereas the details about the involved manufacturers and the manufactured composition could be found in the Module 3 documents. So next, companies are facing challenges in converting Idmp documents, and we are here to provide solutions to these challenges. First challenge is to identify and extract the information in a high accuracy rate, as data and content are spread across many different systems, documents, electronic files. Experience from Idmp projects shows that only about 40% of the required data is in structured format. A full 60% will be unstructured data, buried in documents and other legal systems, making it very difficult to identify and extract. Language is another concern. Products registration in different countries are generally written in several languages, and also duplicates. It is common that we have to figure out which Idmp data is correct when you have extract duplicates of several versions of the same data. There are also inconsistency problem, like which Idmp data is correct when the same data is presented from different sources. Data volume is also a big concern, like how do you handle the massive number of records to investigate, amounting to up to millions of documents for the entire profile. So here is an overview about how we will perform data converting on Idmp documents. We will first extract, load, and transform the Idmp data into the preferred data structure. After that, performing semantic analysis to extract information of interest, and mapping the results to the standardized format. Last, do the data quality check by comparing the extracted results with the gold standard to generate an accuracy evaluation table. So here is one real case example. We used to work with one of the largest pharmaceutical companies in the world. The client would like to extract and convert the Idmp data in a standardized form. Part of the data we got are stored in the PDF files. Others are stored in large image files, like PNG. Each PDF file contains 5 to 7 broad sections, and on average, 30 pages for each document, which means the free text documents are in a very large volume. The information we would like to extract from the original documents are highlighted in yellow color here. They contain product name, reference strength, pharmaceutical form, method of administration, and so on. After we extract them successfully, the next thing is to organize them and map the results to the standardized format. Now we got a general understanding of what kind of Idmp data we have and what kind of information we want to extract. Before I show you the solution part, I want to first let you go through the results, so you may have a better understanding about the challenges we have and the best approach we use in extracting information. Because we have a bunch of PDF files and large image files, and we want to load them in our text mining system and make them into the preferred structure. For each PDF files, our system can systematically convert them into structured data. We can also extract the data if there are tables in PDF file. For large image files, we have the tools called optical character recognition, which is an efficient mechanical conversion of images of typed, handwritten, or printed text into machine-encoded text. And we will have another webinar talking about this topic in the later section. After data loading, next part is about language detection. For medicinal description products, it's quite common that we encounter different kinds of languages. Each language has its own unique challenges. Our system supports 16 major words languages, taking the linguistic features of each of them into account. We are able to detect languages through the analysis of characters used, letters, combinations, frequent articles. Once we know what languages we are dealing with, we can isolate each language and analyze the grammar of each of them. As you can see here, we detect 2 languages from the original dataset, English and Spanish. And we will work on them separately in later analysis. Here is the overview page about the extraction results by using our semantic analysis. The left side is what the original Idmp data looks like after loading it into our system. You can see highlights with blue color and underline. These highlighted part are the information that is being successfully extracted. On the right side are the summary list of all the information being extracted in this single document. By clicking single one of them will drive you to the place where the information is being identified and extracted. We can also check some of the results here. We are using the public data as an example, and you can find these documents online, so the data is safe. If we click the first highlighted part, the pop-out window will show you the details about the attributes of the extracted results. As you can see here, the first section being extracted is called name of the medicinal product, and the value here is Cetrotide 0.25 mg powder and solvent for solution for injection. The second section being extracted is called reference strength. The value is 0.25 mg sexual relics. And the third section being extracted is called pharmaceutical form. The value is powder and solvent for solution for injection. The first part is called Therapeutical indications. The information here is a long text description about indications that this medicine may have. Along with the text documents in English part, we can also extract information for Spanish part, and you can check part of the results here if you know what they mean in Spanish. So next is the solution part. There need to be multiple steps to eat an elephant, from data loading, data preparation, data mining, information extraction, result mapping, and result quality check. Because of time constraint, today we will only focus on the information extraction part to show you how we are using our coding system to extract target information. Okay, let's move ahead and talk about the method we use for this task. So in the pharma industry, there are a variety of potential options for the Idmp data extraction. One solution is by using machine learning. There are two main benefits we can get. One is that it is good at identifying new patterns and trends that might not be apparent to a human. Another benefit is that it could work without human intervention. There are also cons about machine learning. One single error can cause havoc within a machine learning interface, as all events subsequent to the error may be flawed, and these errors can be caused by ambiguous words or jargons in text documents. And also, it's important to consider whether you can invest the amount of time and high-quality resources to develop the technology to a point the result is useful. The advantage of detecting patterns by using machine learning is not very valuable here, comparing with the potential errors it may cause. And that's a major reason why machine learning is not the best approach. Another solution, and the solution we're using, is the semantic analysis by using the language coding system. It is the process of relating semantic structures from the level of phrases, sentences, and paragraphs to the level of the writing as a whole. Because patterns in the formatted documents are easy to identify, the results will have a very high accuracy, and the solution we make is easy to adjust and modify. The cons is that it needs human intervention. It means we need to tell the system the potential patterns it may exist in a document, and it also needs expertise to manage the controlled vocabularies. Also, it takes time to list all potential patterns and collect all ambiguous words and jargons. Our well-designed language coding system and advanced dictionary system in our software makes it very easy to identify the keywords and patterns. Next, I will show you how to use the semantic analysis to define patterns and extract information from the data. The language coding system we are using is called the pattern-defined language. We are able to extract and return matched patterns as structured data, as well as any attributes. So here is one example. In the free text, we have drugs named called NSAIDs and its reaction type, and also in total 3 specific adverse effects. We first use our language coding system to extract targeted information. Next, transform them into the structure, into the preferred structure, as you can see here in the following table. The first column is ID, followed by the drug name, and the reaction type, and the 3 adverse effects. Another example here, and the object is to capture records called ibuprofen 200 mg as a whole. Order here does not matter. As you can see in the text document, there are 2 records talking about ibuprofen 200 mg. So we will first capture measurements. Here is the code. And the freeze function finds documents that contains sequence or arguments within a freeze, and their relative order matters here. Term number will capture digital records, and term unit will search for any words that represents units or measurements in the pre-built dictionary. Here is a search numbers and units within one freeze, and the result is 200 milligram. Next, we capture the drug name. The term medicine will search for any medicine words listed in our pre-built dictionary. And that dictionary called medicine contains all potential words that are used to describe drugs. Here, the extraction result is ibuprofen. And last, the code. You can see at the very beginning there is a sneer code. The sneer function finds documents that contain sequence or arguments within a sentence, regardless of their relative order. Here, if the length between measurement and drug name is less than or equal to 2, then return them as a whole. Now, we successfully capture the target information, which is ibuprofen 200 milligram. Next, let's talk about how to capture section name and the detailed information as a whole. The basic idea is to use separated PDL rules to capture them separately and calculate the length between each information and decide if they belong to each other. Here, we first define all possible patterns for the section headers. Then normally start with numbers plus a dot, and followed by the name. Next, we extract the data. Here is a query we just listed one data format. It's digit, slash, and digit. But in the real, it is necessary to contain all possible data sets in your language coding system. And next, if the length between section header and the data is smaller or equal to a certain number, then we will return them as a whole, as you can see here. The length I set here is 3. If the header and the date, the length is between 3 characteristics, then we will capture them as a whole. And during each query, we give each extracted information a proper name and return the result in a result block. Here you can see we convert PolyAnalyst documents from the Idmp format into the standardized format. And the standard format includes the section number, which is 10, and the section name is the date of reversion of the text, and the value is September 24th. So in conclusion, the text mining tool we are using, which is called PolyAnalyst, performs high accuracy with super good performance in extraction. They are excellent and easy process for data verification. Also, we can always edit directly the data in the tool, and we are always looking for the best technical solutions for our client. Okay, thank you everyone for listening, Brian. Do we have any questions here?
Yes, Wilson, we certainly do. As Wilson and I explore some of the frequently asked questions about this topic, please feel free to submit additional questions using this chat box on your screen.